Yo, what's up everyone? It's Prasanna, and welcome back to the channel. Today we're diving deep, and I mean deep, into the world of Android. We're talking about the core, the foundation, the stuff that makes your favorite apps and games actually work. Now, whether you're a seasoned developer or just curious about what makes your phone tick, this video is for you. We're breaking down the complex stuff into bite-sized pieces, so you can walk away feeling like you actually understand the magic happening behind that screen. From the architecture that holds it all together to the secret source of performance and customization, we're covering it all. So buckle up, hit that subscribe button, and let's unravel the mysteries of Android together. All right, let's kick things off by peeling back the layers of Android, like we're disassembling a brand new gadget. First up, we've got the foundation, the bedrock, the Linux kernel. This bad boy is all about handling the core system functions. Think memory management, security, and making sure all the hardware plays nicely together. It's like the behind-the-scenes crew making sure the whole show runs smoothly. Next, we move up to the libraries layer. This is where things get really interesting. We're talking about pre-built code libraries for everything from media playback and graphics rendering to databases and web browsing. Think of it as a massive toolkit that developers can tap into without having to reinvent the wheel every time. And then we have the Android runtime, the engine room of the entire system. This is where your apps come to life. It's like the interpreter that translates your app's code into instructions that the device can understand. We'll delve deeper into the art later on, but just know it's all about speed and efficiency. Now, sitting pretty on top of the runtime, we have the application framework, the layer that ties everything together. This is where you'll find all the high-level services that your apps rely on, like the Activity Manager, the Notification Manager, and the all-important Window Manager. Finally, at the very top, we have your apps, the stars of the show. This layered architecture is what makes Android so flexible and powerful. Each layer builds upon the one below it, creating a robust and versatile platform for developers to work their magic. Let's circle back to the bedrock, the foundation, the Linux kernel. Now, you might be thinking, wait, isn't Linux the open source operating system for computers? And you'd be absolutely right. But guess what? Android actually borrows the Linux kernel as its core, and that's a big deal. You see, the Linux kernel is like the ultimate multitasker. It handles all those low-level tasks that we often take for granted. It manages the device's memory, making sure each app gets what it needs without hogging resources. It ensures the security of the system, protecting your data from prying eyes. And perhaps most importantly, it manages the processor, or CPU, deciding which tasks get priority and how much processing power each one gets. Think of it as the conductor of an orchestra, making sure all the instruments are playing in sync and at the right volume. This efficient resource management is a key reason why Android can run on a wide range of devices, from budget-friendly phones to powerful flagships. It's all thanks to the Linux kernel's ability to adapt and optimize for different hardware configurations. So next time you're whizzing through your favorite apps, take a moment to appreciate the silent hero working behind the scenes. The Linux kernel, keeping everything running smoothly and efficiently. Now, let's talk about where the rubber meets the road, the Android runtime, or ART for short. This is where your app's code, written in languages like Java or Kotlin, gets translated into something the device can actually understand and execute. You see, computers think in binary code, a series of zeros and ones, but we humans, we like our programming languages a little more, shall we say, user-friendly. That's where RT comes in. It acts as a middleman, converting that human-readable code into machine-executable instructions. Now, before ART, there was Dalvik. It was the original runtime for Android, but it had its limitations. It used a just-in-time compilation approach, which meant the code was translated as the app needed it. This could lead to some performance hiccups, especially with more demanding apps. But then came ART, like a software upgrade on steroids. ART introduced ahead-of-time compilation, which means your app's code gets translated into optimized machine code when you install them. This results in faster app launch times, smoother performance, and even better battery life because the CPU doesn't have to work as hard. It's like the difference between having a translator on call and having your favorite book already translated into your native language. You can just dive right in and enjoy the experience without any delays. And that's a big win for Android users everywhere. Okay, let's talk about the unsung heroes of the Android World System Services. These are like the behind-the-scenes crew that keep everything running smoothly, even if you never see their faces. We're talking about essential services like the Activity Manager, the Package Manager, and the Window Manager. The Activity Manager is like the stage director of your phone. It's responsible for managing the life cycle of your apps, from the moment you launch them to when they're running in the background and even when you close them. It makes sure everything happens in the right order and that your phone's resources are used efficiently. Then we have the Package Manager, the librarian of your phone. It keeps track of all the apps installed on your device, manages permissions, and makes sure everything is up to date. It's like having a personal assistant who organizes all your apps and makes sure they play nicely together. And let's not forget the Window Manager, the master of your phone's display. It decides how your apps are displayed on the screen, manages multiple windows, and handles all those touch interactions you make. It's like the conductor of a visual symphony, making sure everything looks crisp, clean, and responsive. These system services, and many others like them, work tirelessly in the background to provide a seamless and intuitive user experience. They're the unsung heroes that make Android the powerful and versatile operating system we know and love. Now let's shift gears and talk about the tools that developers use to build those amazing Android apps we love. Enter Android frameworks, a collection of pre-written code libraries and APIs, or application programming interfaces, that act like building blocks for app development. Think of it like this. Imagine trying to build a house from scratch. You'd need to source every single material, cut the wood, lay the bricks, and figure out the plumbing and electrical systems. It's a daunting task, right? Well, Android frameworks are like prefabricated walls, windows, and doors for app development. They provide developers with ready-made components and functions so they can focus on building the unique features and functionalities of their apps without having to reinvent the wheel every time. For example, Android frameworks provide UI components like buttons, text fields, and menus that developers can easily incorporate into their apps. They also provide access to system services like location services, camera access, and notifications, making it easier for developers to create rich and engaging app experiences. This modular approach not only speeds up app development, but also ensures a more consistent and reliable user experience across different Android devices. It's like having a universal set of building codes that guarantee a certain level of quality and compatibility. Let's talk about the bridge between the digital world of software and the physical world of hardware. The Hardware Abstraction Layer, or HAL for short. You see, Android is designed to run on a wide range of devices with different processors, screens, cameras, and sensors. Each of these hardware components has its own unique way of communicating and interacting with the software. This is where HAL steps in like a universal translator. It provides a consistent interface for Android to communicate with different hardware components regardless of their underlying implementation. Think of it as a diplomat, smoothing out the communication between different countries with different languages and customs. HAL allows Android to be hardware agnostic, meaning that developers can write code that works seamlessly across different devices without having to worry about the specific hardware details. This is crucial for Android's open ecosystem, where manufacturers can customize their devices with different hardware components without breaking compatibility with millions of apps. For example, let's say you're a developer building a camera app. Instead of writing different code for every single camera sensor out there, you can use the Camera API provided by Android, which interacts with the HAL to handle the communication with the actual camera hardware. This abstraction layer simplifies app development and ensures a smoother and more consistent user experience across a wide range of Android devices. It's one of the key ingredients that makes Android so versatile and adaptable. Now let's talk about another secret weapon in the Android developers' Arsenal Android libraries. These are collections of pre-written code that provide specific functionalities like image processing, networking, or database management. Think of them as specialized toolboxes for different programming tasks. Instead of writing all the code from scratch, developers can leverage these pre-built libraries to save time and effort. It's like having a team of expert craftsmen at your disposal, ready to handle specific tasks with precision and efficiency. For example, if you're building an app that requires image editing features, you can use a library like Glide or Picasso to handle image loading, caching, and manipulation. This saves you from having to write all that complex code yourself, freeing you up to focus on other aspects of your app. Android libraries not only speed up development, but also promote code reuse and maintainability. By using well-tested and widely used libraries, developers can ensure that their apps are more stable, reliable, and performant. It's like using high-quality ingredients in a recipe. You're more likely to end up with a delicious and satisfying dish if you're not starting from scratch with every single ingredient. And that's what Android libraries bring to the table: pre-built power and efficiency for app development. Let's take a closer look at the beating heart of the Android system, the system server. This crucial component is like the central nervous system, managing a wide range of essential system services that keep everything running smoothly. Think of it as a grand central station where all the different system services like the window manager, the notification manager, and the audio manager come together to coordinate their efforts. The system server is responsible for starting, running, and managing these services, ensuring that they have the resources they need and that they're playing nicely together. It also acts as a mediator between these system services and your apps, facilitating communication and resource sharing. For example, when you open an app that needs to play audio, the app doesn't directly communicate with the audio hardware. Instead, it sends a request to the system server, which then communicates with the audio manager to handle the audio playback. This centralized approach ensures that system resources are used efficiently and that different system services can work together seamlessly without interfering with each other. It's like having a well-coordinated team working behind the scenes to make sure everything runs smoothly on your Android device. So, the next time you're enjoying a lag-free gaming session or seamlessly switching between multiple apps, remember the system server, the unsung hero keeping all the plates spinning in the background. Now let's dive into the fascinating world of inter-process communication, or IPC for short, and how Android uses a mechanism called Binder to make it all happen. You see, in the Android world, different apps and system services often need to talk to each other to share information or request actions. For example, your music player app might need to tell the audio service to start playing a song, or your Maps app might need to request location data from the location service. But here's the thing, each app and system service runs in its own isolated process, like separate rooms in a large building. This is where Binder comes in, acting like a secure and efficient messaging system that allows these isolated processes to communicate with each other as if they were in the same room. It's like having a network of pneumatic tubes that can quickly and securely transport messages between different parts of the building. Binder handles all the complex details of inter-process communication, such as data serialization, security checks, and process management. This allows developers to focus on building the core functionalities of their apps without having to worry about the intricacies of IPC. It's like having a dedicated postal service that handles all the logistics of sending and receiving mail, so you can focus on writing the actual letters. And that's what Binder does for Android. It connects the dots between different processes, enabling seamless communication and collaboration. Finally, let's talk about how Android manages to keep everything running smoothly without draining your battery life in a matter of hours. One of the key strategies is how it handles background processes, those apps that are running behind the scenes even when you're not actively using them. You see, in the early days of smartphones, background processes were like energy vampires, constantly sipping on your battery life even when you weren't using them. But Android has come a long way since then, introducing sophisticated mechanisms to tame these background processes and optimize battery life. One such mechanism is doze mode, which kicks in when your phone is idle, like when it's sitting on your desk or overnight. Doze mode puts strict restrictions on background processes, limiting their network access and CPU usage. Another mechanism is app standby, which prioritizes apps based on your usage patterns. Apps that you use frequently are allowed to run more freely in the background, while less frequently used apps are put into a lighter sleep mode. Android also provides developers with tools and APIs to build battery-friendly apps. For example, developers can use Job Scheduler to schedule non-urgent tasks to run in batches when the device is charging or connected to Wi-Fi, further reducing battery drain. This combination of system-level optimizations and developer tools has made Android much more power efficient over the years. It's a testament to the constant innovation and refinement that goes into making Android the powerful and versatile operating system it is today. And there you have it, folks. A deep dive into the inner workings of Android. We've covered a lot of ground today, from the foundational layers of its architecture to the intricate mechanisms that keep everything running smoothly. Hopefully you've gained a newfound appreciation for the complexity and sophistication of this amazing operating system that powers billions of devices worldwide. If you enjoyed this deep dive, be sure to give this video a thumbs up. Subscribe to the channel for more tech explorations and hit that bell icon so you don't miss out on future videos. Until next time, keep exploring the fascinating world of technology.